Dobrodošli nazad u Logintelligence 2020. Evo, približavamo se i kraju, došli smo do zadnjeg predavanja današnjeg dana. Vjerujem da je vama svima bilo zanimljivo čuti stvari koje su se događale do sad. I'm going to switch to English now because our next presenter is also an English native speaker. We will be hearing from John Durnford, Managing Director at Fetch Robotics. His subject is autonomous mobile robots. As you know, the automation and robotics are the future, and Fetch Robotics will show how autonomous mobile robots can bring large increases in productivity and organization and increase the safety of movement inside the warehouses. I'm sure we heard a little bit about during the Kerber's lecture because they are partners, and I'm looking forward to hearing more from John himself. John, can you hear me?
I can. Thank you. Can you let me share the screen?
Just give me a second. I'll switch to you. There, you should have the notification. Excellent. Just go inside the presentation.
You can see the screen now?
Yes, yes.
Okay, excellent. Hang on, there's one thing.
Excellent.
Okay, so Sandra, thank you very much. As Sandra says, I am a native English speaker, but I will try some Croatian. I will say Dobar dan, dame I gospodo. I'm afraid that's all I can say. And I said, I'm delighted to be here virtually, and I just hope that this time next year we will be able to do this in person, so I can meet you all. So I'm going to be starting by giving you by playing a very quick video, because not all of you may be familiar with how autonomous mobile robots move around. So I will just play a very short clip to give you an overview. Right, so that hopefully has given you an overview of what we do. Now, I was very impressed by the question that was asked at the end of Rebecca's presentation. Are people important in the logistics of the future? Absolutely, and this is a theme that I will be addressing several times during this presentation. So, as you can see from the heading here, what we aim to do is to use cobots, which is basically co-workers and robots into one word, and to basically to free them from doing the jobs that are dull, dangerous, and repetitive. And Rebecca mentioned this earlier on. So instead of having people really not doing much in terms of value add, just pushing a cart or a tote or a trolley around, or sometimes driving a forklift, what we want to be able to do is to allow these people to do something much more productive and automate those very simple tasks. Now, just you will be familiar with the companies like Zebra and Honeywell and Corba who have made presentations before. You probably won't be too familiar with Fetch. So just very, very briefly, we are a Silicon Valley based company. One thing that one big message I want to give you is that whilst what you see are the robots running around, in Silicon Valley today, there's not much silicon, everything is software driven. And so if you look at Fetch, nearly all of our IP, and what makes us very, very special is the software that we are producing, which is making the robots run effectively, efficiently, and safely. And those are the key fundamental value propositions that Fetch has. Just one little thing. Where if you do some research on autonomous mobile robots, you will see our CEO and many of her senior team are recognized as being industry leaders. These are people who have actually developed some of the core robot operating systems which are used by many other companies. So we do have a very, very good reputation in this emerging world of robotics. Now, again, I am not going to spend a huge amount of time on this. This slide speaks for itself. And again, Rebecca mentioned this and everybody else has mentioned this. So you are all facing a lot of challenges, which you hear delivery expectations coming down, labor shortages going up, etc., etc. Those are your classical issues and your classical challenges. But since March last year, we have had, as an industry and as a worldwide, we've had another issue, which is basically this horror of COVID. And one of the good things is very simply that autonomous mobile robots don't catch and they don't transmit COVID. Now, one of the things that we have been asked quite a lot, I'd say, in the last 2 or 3 months, is that as people are understanding how to deal with COVID more and more in terms of cleaning and sanitizing, nonetheless, there has been some reluctance by some workers in some countries to actually go back into the workplace, because no matter what management tells them, they are concerned that the place may not have been properly cleaned. I don't know whether this has happened to you in your own facilities, but given the number of calls that we have received recently, this seems to be a phenomenon that's happening all across Europe. And of course, what the autonomous mobile robot does is it gives you that resilience to allow for those jobs to be done, whether the workers are there or not. So what we're looking about, again, these are two themes that we'll be returning to very often, is that by, again, going back to the question about the impact of people in logistics, basically, as you can see here, what we're talking about is a dynamic orchestration of humans and robots. We are not looking at a world where humans vanish. It's very much empowering the workers to be able to work much more efficiently. So again, this is all good stuff, but all theoretical. Now what I want to do is to play another video, this time from a company such as yourself. This is DHL Logistics, who have been using our robots now for a couple of years.
When I think about how robotics can impact the logistics industry, I look at robots as an enhancement to the capability of people, enabling them to do tasks faster, save energy, and get a higher efficiency.
At DHL, we are piloting and implementing the first wave of collaborative robots in a workforce. Solutions such as the transfer robots from Fetch can empower workers and help us to achieve higher levels of safety and productivity in a warehouse.
By further automating unnecessary tasks like moving of goods from point A to B, we can give the employees more rewarding responsibilities and work.
Most of our customers are focused on a fast return on investment. This means deploying systems rapidly and maintaining them very simply by enabling our customers to set up fast and flexible workflows so that a worker can load a robot very simply, press a button, and have it go to its destination.
For us, safety comes first on the work floor, and as the robots combine data from multiple sensors to get a picture of their surroundings, they work safely with and around people. What we found positive was that the system was implemented in only a few days, and we did not need to install any additional hardware. So you can manage multiple robots on a single map, which gives great real-time visibility.
You don't need to know any programming in order to manage the fleet. Intuitive software teaches users how to orchestrate the robots to work together in a dynamic environment. Our robotics system is up and running and has already saved our operators walking up to 32 kilometers per day. What is quite impressive is the flexibility of the solution and how easy it is to adjust to our needs.
Together with our partners, we will accelerate the widespread adoption of robots across DHL to improve productivity and quality for customers, as well as enhance safety for employees. We're excited for what's still to come.
So I'd like to have a look at in maybe just a little bit more detail about some of the tasks that the robots can do. And we have different robots, as you saw from the initial introduction, able to do different tasks. So this robot here we call the Cart Connect, and the idea is that you can disassociate the cart from the robot. The cart can be left standing while somebody is picking into the cart, and then when that task is being completed, the robot will now come, engage with the cart, and take it to wherever it needs to go next. So typically, as you can see here, pick the cart, put away, and again, for those of you who work in a manufacturing environment, not just a TNL, you can imagine this as part of a line-side delivery or part of a Kanban system. So the second small robot we have is one that is basically designed to be no touch. What it's doing is it has a powered roller on top. It will engage with a conveyor belt. It will then discharge the tote or the carton when it comes to the conveyor belt, and then it will do exactly the same, going in the opposite direction. And again, you can read the sorts of use cases where we see that. So I would call this, those of you working in what I would call a conveyor heavy environment, this robot we have found to be extremely effective. And then the last small robot that I want to draw attention to is what we call the HMI shelf. The main interface is a touch screen which you can program in any language, and you can very simply have 2 or 3 commands there where you say go to dispatch, go to receiving, go to quality control. So extremely simple commands for the people to work with. And we see this as more for point-to-point type operations, so reverse logistics, express orders, very simple operations. And then we come to a range of robots we have just launched. The aim of these robots is to be able to move much bigger loads, so loads up to 1,500 kilograms, and clearly able to move pallets. Whether the pallets can be full case picking, or again just moving empty pallets around a facility, or moving waste management around. And to give you an idea as to how this works and how the pallets can be put on and off the robots automatically, again, I'm going to play you just a very quick video. So I'm stopping the video there because it gets a bit repetitive, but it gives you an idea as to how the robot can engage automatically with a pallet from some form of a pickup and drop-off station. Now, this slide here I've put up because it gives you a brief overview of a case study that we have with Arrow, the big electronics component distributor in the United States. But what I want to draw your attention to is this here, is goals. Robots can have and will already and will have an increasing role to play in transport and logistics. But like anything in life, there is no magic. And success comes from having some well-defined goals and well-defined objectives. And this is one thing that if those of you who really want to get into this arena, I would really encourage you, as you start your discussions with Pizza, is to think about what do you want to achieve, because what we have seen is companies like Arrow that come to us with some very, very clearly well-defined goals, as you can see here, are the companies that tend to have extremely good results afterwards. Just saying, we're interested in autonomous mobile robots, that's one thing, but having a very, very precise end outcome in sight is something that leads to great success. So it's something I think that I'm sure that the Pizza team will be talking to you about. Now, this next video, there is no sound. It's a bit slow-mo to begin with, so I will just let it play. One thing I should have said before I played the video: this clip is taken inside a 3PL who is the partner company of Nissan Manufacturing in Tennessee in the United States. They have the contract to supply all of the components going into their automotive plant. They have a 45-minute KPI from the moment that the order is received until the goods must be delivered line side. So you can imagine that reliability is absolutely essential to this use case. Now, another use case that I want to draw attention to is that what you've seen so far in the videos has been one robot doing one task and another robot doing another task. This is an example of a company in the United States that is big in home improvements, something that could like in France, Castorama or Leroy Merlin, or in Germany, something like Bauhaus. So an organization which deals both with the general public and with artisans, people like the plumbers, the electricians, and builders. And what they have is they have two different work cases, use cases for us. The first one is the movement of hazardous materials, and this is in one of their distribution centers. And what happens is the hazardous materials are stored in a certain area, and their rules of engagement are that the hazardous materials should be moved the very last items before going into the truck. And so what they have is that the non-hazardous materials are receiving the information from the WMS system and these are picked first. So you could imagine the hammers and the nails and the drills. These are picked and then sent to the dispatch area. But when that part of the picking list has been completed, and only then, they will use the HMI shelf. If you remember, the product that I said is typically used from point to point for express deliveries. This will then be loaded with the hazardous materials, the paint strippers, the varnish, and items like that, and it will go immediately to the docking area. And the assumption is that the rest of the truck will already be loaded, and the hazardous material spends the minimum amount of time on the shop floor. And this company is absolutely delighted with the way that it's worked, because they have gone from having something like 8 or 10 times a day when trucks would be waiting 10 or 15 minutes for the hazardous materials to be delivered because somebody forgot, or there was no person to take the hazardous materials to the door, to now they're down to either 0 or 1 per day. So they have seen an enormous improvement in productivity. And so they had an ROI there of less than 12 months. There is also a second use case that they have. And I mentioned before about the being used by artisans. So you're the plumber, the builder, the electrician. And what they have, this is an American term, we don't even have it in English. They call it will call, which means I will call in without an appointment to this warehouse to pick up the goods that I need. And in this particular company, they have a separate reception area for the artisans. Before, the artisans would typically have to wait something like 20 minutes whilst their order was picked and then dispatched to them. Now with the robots, they're finding that they only have to wait 5 minutes. So of course, as the word gets out, they are seeing much more business, because for these artisans, time really is money. So again, it's a very practical example of how robots can impact not just the general efficiency of an organization, but again lead to some big benefits for their customers. So just a little bit of a heavy sell from me now about Fetch Robotics and what makes Fetch different. Rebecca hinted at this, or did more than hinted, that she outlined some of the benefits of what we do, and it really comes down to speed of implementation, speed of deployment. We are a 100% cloud-based company. We need no infrastructure when we go into an environment. The only thing we actually need is access to a strong Wi-Fi signal, and we don't even ask you to put in a new Wi-Fi network. We are very happy to piggyback on whatever you cost or whatever you have installed. And as Rebecca is maybe a little bit more aggressive than me. We say, me being English, a little bit conservative, we say that we can deploy generally within a maximum of 3 days. But Rebecca is absolutely right. There have been many occasions where we have deployed in half a day or one day. But again, I don't want to oversell. It doesn't happen by magic. What we've said is absolutely true, but before that happens, clearly there has to be a site analysis, there has to be a statement of work, there has to be us or Spitzer doing a walkthrough to understand that the robots can move easily and freely and safely through the environment. But having said all of that, once those criteria are met, absolutely, we can have a very, very fast deployment, which means that you are seeing an immediate impact and an immediate benefit in your premises. The other thing is that, again, Rebecca mentioned this, is that we can scale. So because everything is cloud-based, the robots are shipped with the maps already in their brains, and you unpack the robots, they are ready to go. They are immediately productive as you scale. And one of the things that I was showing in a few minutes' time is that we have a huge amount of confidence in Spitzer. We know their strengths, and so do you. But also, I'm sure that there are many times when you want to be able to basically understand that you can do mapping yourselves and you can do many other tasks yourselves. So again, we are giving Spitzer's customers the ability to have a huge amount of flexibility with the way that post-deployment you manage the robots. So I mentioned that we're cloud-based. In an earlier slide, I talked about how all of our IP really revolves around the software. So what we call it Fetch Core is doing several things. It's driving the robots themselves. Very, very importantly, it's allowing Spitzer to work with you to do the integration into, say, the core into the Corba system, either doing a full integration, or if you want to just automate a very simple A to B task, which you saw, for example, at DHL, that DHL initial environment was not fully integrated. They were using some simple SDKs and some simple triggers from handheld scanners or other devices to basically call the robots to go backwards and forwards. So a big message to all of you is that you don't have to be concerned about starting with a full integration, which of course takes a lot of time. You can start in a non-integrated environment and basically have the robots working extremely quickly. And the last thing I want to talk about here is analytics. We live in a data-driven world. Anybody involved, especially in logistics, again, there was a whole presentation on KPIs. Data KPIs is really driving efficiency. So what we can do with our robots is that we can show you really simple things. For example, we can show you the number of deliveries per day per robot. We can show you the distance traveled robot by robot. And again, this is not real data, but it's just giving you an idea that if you have a range of robots and you can see 4 times efficiency in distance traveled, or 4 or 3 times the amount of deliveries, it's now going to give you the data so that you as managers and logistics experts can start to ask the questions, well, why is one robot or one task or one route performing so much more efficiently than the others? So it's giving you the data to really start to ask those questions. And then as we look to the future, we know that those of you who are involved in anything to do with picking, how you're measured is LPH or UPH, and what we want to be able to show, again, especially with the Corba type of software, is the impact of associating some sophisticated software with a robot, which together will help you drive the UPH and LPH. And again, these are all figures that we in Corba and various other people, we will be able to show you to help you manage your business better. So again, Rebecca mentioned this very briefly, but I want to follow up. I want to just a slightly more detail. So how does all this magic take place? Well, very simply, there are 2 different types of sensors that we have that are important to you for this presentation. Number 1, a laser scanner, which is projecting, as you can see, 25 meters in front, which is basically how the robot finds itself in the environment. And then we have 2 3D cameras, which are all about safety. So what happens is that as we take a robot into a new environment, we walk it up and down the shelves, and as you can see here, that laser is picking up anything which is basically metallic. So this is the raw data from which the robot is going to find itself around the world. And then inside that world, what we then have to do, what Spitzer will do and what you will be able to do, is you can then start to impose some rules as to how the robot works. So Here you can see shelving or stacking. You don't want the robot driving into that. So basically what we do, we just color this red, which is a no-go zone. In the planning process or the mapping process, you will probably find some things like pallets that are lying around, or maybe a forklift which is idle. We color this in green because that tells the algorithm ignore what's there. And then what we have in this column here, we color this in orange, and this is what we call a speed limited area. Not because we're worried about the speed of the robot, but because we want to make sure that the forklift drivers, where we know there's a lot of forklift movements, have the time to see the robots. So those are what those colors are. And again, this is like using paint. It would take you, ladies and gentlemen on this call, 5 or 10 minutes to learn how to do this. And then what we do, we start to superimpose the routes. And we have two different types of routes. This route here in purple is what we call a fixed route. And you can imagine this is more for manufacturing. So going from, say, a manufacturing supermarket, dropping off at predetermined points items for induction into the manufacturing line. And you don't want any deviation. So this is what we call a fixed route. And we have that in purple. But those of you who spend most of your time in the logistics area and picking, you know this is a much more dynamic environment. So here you want the robots to be able to pick up from basically any of these points here. And then once it's finished the picking cycle, to find the fastest possible way to what you could imagine would be the dispatch area. And all of this, like I say, all of this route laying down and everything else, this is something that Speedster will be able to train you within, like I say, within 10, 15 minutes, you will be up and running. And again, very importantly, you will be able to manage this on your own once you have been trained, because you are all working in dynamic environments. And again, I don't want you to get the impression that this is a huge amount of learning and software skills to be done. As that gentleman in the DHL video said, you don't need to be spending, you know, your staff on a 2-week training course. Again, this doesn't require any big software skills. And again, within half a day, your team, and certainly the Speedster team is already trained to do this, can basically do the simple integrations into your environment. And everything here is drag and drop. So we mentioned safety. The safety is everything with these robots, especially on the big robots. And what I wanted to do with these a couple of videos here, or a couple of clips, is to basically show you what the human sees and what the robot sees. The reason that I mentioned this, I have this one first. This is really showing sensor technology. I am sure that some of you will be thinking about, well, what about GDPR? You know, are we capturing people's faces or any other information? And here you can see, no, we are not capturing any information at all where you could recognize a human being. This is the image which is downloaded to our files. So, like I said, this is what the human sees. This is the robot representation. But then when we come to safety, let's have a look at another couple of clips. So we'll let that play again. You can see the robots coming down the alleyway. Here's the cart. We don't want to hit the cart. The robot's using those 3D cameras. Once the cart has gone by, the robot will then move. And in any environment in a warehouse, you have something like this. On the right-hand side, you have the forklift. On the left-hand side, you can see how the robot sees that forklift and then safely navigates around it. And the final one here that we have is where you have these overhanging items, which unfortunately will happen inside even the best kept warehouse from time to time. Again, you don't want the robot running into those. And you can see on the left-hand side how the robot sees the environment and then avoids the obstacles. So safety is absolutely fundamental to this. You are putting a device that's running around, say, where the small ones are 100 kilograms, the big robots up to 1,500 kilograms. It is absolutely essential that safety comes first, second, and third. You saw the video clip earlier on with Melanie, our CEO. She is fanatical about safety, and it's an area where we will not compromise. So trying to tie together some of the different threads now with this with the presentation, what I want to show you now is basically how augmented reality and how relationship that we have with some of the other big vendors is going to start to play out to bring some big increases in productivity to a picking environment.
Organizing the warehouse into zones. Fulfillment Edge can utilize existing location labels or print new ones via a Zebra mobile printer and use them to generate virtual layouts to be used when directing an associate visually via the Zebra HUD to the correct aisle, rack, and/or pick slot. This location is then divided into zones to keep associates walking less and moving more. We will use the new Zebra HUD and Bluetooth ring scanner to create a frictionless hands-free user experience for the associates. Pickers stay in their zones and will pick directly onto a cart loaded on a robot. When the last pick in the zone is complete, the robot will automatically move the cart to its next task, whether that is more picking in other zones or the packed ship station. The associate starts the picking process by scanning the order totes to record their position on the cart. This is used to visually guide the user what quantity of picked item goes in what order tote. Now the HUD directs the associate to the correct aisle, rack, and pick slot. If the picker scans the wrong rack, the HUD provides visual guidance on how many racks to move in the right direction. The associate is notified on the HUD that a priority order has arrived and needs to be picked next. He is directed to the correct aisle and rack. Fulfillment Edge dispatches a roller top robot to the pick location. It notifies the associate that the robot is on its way. The associate picks the priority order, drops it into the tote on the roller top, and scans the item into the bin. A message on the HUD confirms the priority order is now complete, and the roller top robot proceeds to the drop-off conveyor. Along the way, it encounters the Cart Connect robot, Fulfillment Edge.
Right, so that gives you an idea of how robots and humans and augmented reality are all going to be not just into the future, but this is actually happening today. Now, one of the themes, or one of the things that's been talked about has been the impact of COVID. And I talked about it a bit earlier on. So in addition to having robots, which basically can work in any sort of environment and don't catch COVID, we actually in the United States have just developed some robots with some OEM partners, which can go around a warehouse and can actually disinfect a warehouse. So this particular technology, they can disinfect 10,000 square meters in something like one and a half hours. So just to give you an idea again how we are working with people to bring real solutions to the real world. Now, again, like I said at the beginning, I'm really pleased that we are partnering with Spitzer. Spitzer is a company I've known for a long time. I think it's a fabulous company, and I would just like to say that we are bringing some very new technology, new solutions to Croatia, Slovenia, and to the Balkans, and it's very important for us to know that we have a partner who is absolutely on top of this. And so this is what I think are the big value adds for everybody on the call here, is that all of you will have a WMS system. Spitzer know how to do WMS integration. Spitzer have a fantastic track record of doing basically implementation, training, and deployment, of providing great after sales and support, and they have offices all through the Balkans. So I am really, again, I cannot say how delighted I am to be partnering with Spitzer. And the final slide I have, again, really goes back to that question that was asked. Are people important in logistics of the future? Well, the answer is absolutely yes. And again, this, as you can see, this is a pre-prepared slide, so this is not something I've had the time to do in a reaction to that question. But I've talked a lot about robots, but again, I do want to finish with this slide, and this is very, very serious, that people are the key to productivity and efficiency. We are not going to be going into dark warehouses in the next 10 or 15 years. People will be needed to work alongside the robots, to feed the robots, and to basically have their jobs made much more efficient. And so the big message I want to give you here is really, again, picking up on a theme that Rebecca said, it's all about involving the staff right from the beginning, but really it's before the beginning. Where we've had great deployments, like you saw at DHL or John Deere in Germany, they have worked months before the robots were deployed by working with the works councils, explaining to people what the robots are going to do, why they're going to do it, how they're going to make the people's lives much easier. And I guess one of the big proofs of this is that what we see probably after about 3 or 4 weeks of the robots being there is the staff coming up to the managers and saying, well, the robots are doing this task, why can't they do another task? And I think that is a great endorsement of what the technology can do. So that's the end of my formal presentation. I think there are a few minutes where we can have some questions.
Thank you very much, John. That was very interesting lecture. Actually, we do have a few questions. I was just wondering, because they arrived maybe in the middle of the presentation, so maybe you you dealt with some of them. So the first question would be, the person who asked the question says that he works in a forklift heavy environment, and basically sometimes forklift drivers are using, because they are used to the route, they are driving pretty fast. And the problem is the robot actually doing only stop when they see the collision, imminent collision in front of them or the object, or they have some sort of an avoidance technique? And if so, if not, are you planning to implement something like that?
Yes, well, I hope that one of the slides that I showed, the slides that I showed did talk absolutely about the avoidance technique. But again, again, this is all working off a very sophisticated algorithm. So at one extreme, if you saw a forklift that was stopped in the aisles, the algorithm would basically say, okay, this forklift is stopped. So the algorithm would then basically go into straightforward avoidance technique, just like you saw in one of these slides. So in one of these slides here. On the other hand, if the robot sees that there is movement by the forklift and that is potentially a collision, then again, as you would have seen in this video clip here, the robot will stop, will either stop in its tracks and then let the forklift pass. So it all depends on how the algorithm perceives what the object is doing, in this case a forklift.
Thank you. We have one more question. Who triggers the need for the robots, VMS or a person? And can it be triggered by outside systems?
Yes.
For example, yes. Voice systems.
Yeah. Yes. Absolutely. So again, slide here. Yeah. So if I look at this slide, here, so yes, so it can be the WMS is one way of doing it. That is the full integration. Or like I said, you can use a really simple device like a handheld scanner or a tablet to give a very simple command. And also, of course, you can use voice. So basically, we can take, I think the short answer is we can take any digital input to be able to ask the robot to come and the robot to go or the robot to stop.
Well, that's very useful, very flexible, that is. And we have one controversial question. How many people can one robot replace? And do we still need people in the warehouse?
Right. Yeah. So, well, hopefully during the course of the presentation, I answer that. So, it depends. So basically, that's a very difficult question to answer without knowing a particular use case. But generally, what we say is that if you have multiple people spending multiple hours a day pushing a cart or pushing a trolley or even driving a forklift, then what you should be looking at is basically a one-to-one of a combined headcount. So if you have, let's just say you have 3 people spending a third of their day pushing carts around, what you would be able to do is to basically release each of them to be more productive for 1/3 more of their time. So that is one part of the answer. The second part of the answer is, do we foresee a time when there will be no people in warehouses? Probably not for quite a long time, because like I said, there are tasks that robots cannot do. The robot today cannot do the picking. The picking is done by a human being, and the human being then puts what has been picked onto the robot. There is no magical robot arm. So to answer the question, I don't think that's going to be happening for quite a long time.